Hello friends, welcome to my channel. So today in this small Snowflake architecture video, we will see 5 mostly asked interview questions about the Snowflake storage layer. Before we go to the questions, I will briefly explain the fundamentals of Snowflake storage layer so that we can understand the questions as well as their answers. So let us quickly start. So we know that Snowflake has a 3-layered architecture. First is the cloud service layer, then is the query processing layer, and at the bottom it is the database storage layer. The sole purpose of database storage layer is to provide data storage mechanism for the tables within the Snowflake account. Now, in Snowflake, for any table, irrespective of the number of columns or the number of rows, it is going to have all the data by default is stored into micropartitions. So to understand the database storage layer, we need to understand the internals of micropartitions. So let us see that. So by definition, a micropartition is a subset of complete table dataset which is arranged in a specific format to store the data. Now, what happens when we load data from a file into a table? So first of all, this data from the file is split into a number of micropartitions. The number of micropartitions is not decided by a user. It is based on the number of rows and the structure of the table. And then uh, all the micropartitions are compressed and stored into the storage layer. Also, the statistics of these micropartitions are gathered, and then those statistics are stored in metadata layer. Whenever a user queries a table, the Snowflake engine access this micropartition statistics from the metadata layer, based on which it decides which micropartition it needs to read. Then it loads those micropartitions into the memory and then prepare the final output. So let us quickly understand the internal process of micropartitions quickly. So let us assume that we want to load 1 GB file of data into a Snowflake table which has around 1 billion records. So the first step which will happen is the horizontal partitioning of all the records. If you are aware of the partitioning concept in Oracle, it is very much similar. All the rows within the data file will be horizontally partitioned. So let us say that our micro partition can store 250 million records. So for 1 billion records, it will be 4 micro partitions. After the first step, when number of records are finalized, the data of each micropartition is reorganized. What happens within this reorganization is that in Snowflake micropartition, all the data is stored in columnar format. So after the rows are decided, like 250 million rows, those rows will be split into separate columns, and then those columns will be stored into the micropartition. The third step is the compression of the columns. So once the data is stored in the columnar format, each column data is compressed. This is done to reduce the storage consumption of the data as well as increase the performance. After the compression, all the micropartitions are then encrypted and then stored into the Snowflake storage layer. Some of the important points about micropartitions are that micropartitions are immutable files. What does it mean? It means that you cannot modify the data within a micropartition. So one basic question which can arise is, what happens when a delete or update SQL query is fired on a table? So because Snowflake micropartitions are immutable in nature, so whenever a update or delete query is fired on a micropartition, then these three operations happen. First of all, a new micropartition is created which has all the impacted rows by the SQL query as well as all the non-impacted rows by the SQL queries. Impacted rows means that all the modifications are happened and then those are stored in the new micropartition. The second step is that previous micropartition is marked as invalid and it is saved for the time travel, and then new micropartition is marked as active. The third step is that new created micropartition is added to the metadata of the table within the metadata layer. So that's how delete and update operations happen on a micropartition. So the second point is that a micropartition can have a size between 50 MB to 500 MB uncompressed, because what would be the size of after compression, that is unknown in the beginning. The third point is that metadata about the micropartition is stored in the metadata layer, which I already explained. Now, what kind of metadata is stored is that, suppose if it is a string column, then distinct values within that column, those will be stored in the metadata layer. If it is a number column, then a range of values for each micropartition that will be stored in the metadata layer. These distinct values or these statistics helps to identify which micropartitions should be considered while SQL query on a table. Now, when we understand the basics of storage layer as well as the micro partition, let us see what are the mostly asked interview questions on the Snowflake storage layer. So the mostly asked question is, first of all, you will be asked to explain the micro partition and its functions, which we just did. The second usually asked question is, can you access the data of a specific micro partition, and can you control the number of micro partitions being created during the data load? The answer is no. So if you are aware of the partitioning concept in the Oracle, Oracle provides the facility that within an SQL query, you can query a specific micro partition by giving its name. But in Snowflake, all the micro partitions are invisible to end user, and end user does not have any capability to query a specific micropartition by its name or ID. Second is number of micropartitions being created. Snowflake end user does not has any capability to decide how many micropartitions should be created. It depends on the incoming data volume as well as the structure of the table, and Snowflake itself identifies how many number of micropartitions it has to create. The third question is, how does Snowflake gets the storage to store table data? So Snowflake is a SaaS based service, software as a service, and it uses the services of a cloud service provider to provide compute and storage within its own account. So to answer this question, Snowflake uses the storage services of the underlying cloud service provider account, which could be one of three: GCP, Azure, or your AWS account, to provide the storage service to provide the storage for the table data. The fourth question is that if Snowflake account uses the storage services of the underlying cloud service provider account, do you have the capability to log into that cloud service provider account and access that table data? The answer is no. We do not get direct access to that cloud service provider account, which on top of which Snowflake account is created. If you want to access the table data, the only possible way is to go via Snowflake account. The fifth question is, what are the drawbacks of micropartition and how to overcome that? So if you are learning about the advantages of a feature, you should also learn about the disadvantages of a feature and how to overcome that. Now, the disadvantages of micropartition is that you lose the capability of row locking. So in Snowflake, you does not have to lock a specific row and perform operations on that row. The minimum granularity of locking comes at the micropartition level. So this is the main reason that Snowflake is not used for OLTP systems, because their row level locking is required to perform the transactions. And in OLAP system, we need the high read capability. So Snowflake is primarily used for OLAP systems. How to overcome this? In OLAP system, usually data is written in batches. It could be small or it could be uh, a huge volume of data in a batch, and Snowflake recommends to store data into batches via SQL statements and avoid update operations. So these are the mostly asked interview questions about the Snowflake data storage layer. If you find this video helpful, please like this video and subscribe to my channel. See you in the next video. Thank you.